My name is Rosalie de Zeeuw, and I'm a product specialist at Xsens. And together with Lucas Romain, who is a manufacturing process consultant at Siemens, we will highlight how ergonomics powered by motion capture are done with the Siemens Process Simulate software and the Xsens integration. Before we start, first some important notes. This session will be recorded and you will get the recording via an email within a few days. And if you have some questions, please put them in the questions tab so we can touch upon them later. So today, first I will give a short introduction about Xsens and then tell a bit about how you can stream human movement data. And then Lucas will take over and he will first give an introduction about Siemens, about their accelerator and the software Process Simulate. And then he will show how the integration of the Xsens motion capture data within the Process Simulate software is done. And after that, we will have a live Q&A session in which we will try to answer all your questions that you put in that questions tab. So we're happy to have this webinar to highlight an ongoing collaboration between Xsens and Siemens. And what is this collaboration? Well, it's actually an integration of the Xsens data in the Process Simulate software by Siemens. The Process Simulate software will be explained a bit more by Lucas, but to say it a bit in short, this software can be used to design workstations. And while designing them, you want to make sure that how humans move is taken into consideration to make an ergonomically optimized workstation. And by using the Xsens data, you can use actual human movements for that. So for those who are not familiar with Xsens, a short introduction. Who are we? Well, we're a company that creates motion capture technology with inertial sensors for movement digitization. We've been doing that for 25 years now, and with 5 regional offices and customers around the world, we operate globally. And with this global operation, we also have a global ISO 9001 certification. We work for a couple of market segments. One of them is the entertainment markets, the health and sports, also humanoid robotics, and the industrial market segment. And the topic of today, ergonomics, is a large part of our health and sports segment. So using motion capture technology for ergonomics is done quite often now. And why do people choose to use motion capture technology for ergonomics? Analysis is, for example, that you can do your analysis without any bias. So there's no person that has to say, oh, this motion is within or outside of the limits, but it's just a measurement done without the bias. And using inertial motion capture technology also has the large benefits that you don't need any cameras on the workplace. Well, with this ergonomic analysis, you can do real-time adjustment to your workplace, but also use it to analyze it afterwards. And that will result in a better workstation design. And with that improved workstation design, you have an improved productivity, safety, and efficiency. So to do this analysis, we basically have 2 systems for full body motion capturing. And these are the Xsens Link and the Xsens Awinda. The Xsens Link is in the picture on the left, and this is a full body suit with wired trackers. Because of those wired trackers, we can have a high frequency update rate of 240 Hertz. But for more everyday movements, we also have the Awinda system, and that one is on the right. And this one consists of wireless trackers that are attached to your body with straps. And this is very beneficial if you want to wear them in combination with your normal working clothes. So how does it actually work? Well, for a full body motion capture, you will have to set up 17 of our sensors to your body. And every sensor is assigned to a specific segment. And we have tutorial videos on our website showing how to correctly position them. Well, after you put all the sensors on your body, you have to launch our software and then do a calibration. And during that calibration, the sensor data is mapped to our biomechanical model, and a lot of algorithms are applied to come up with a human movement digitization. Well, this calibration consists of 3 parts. First, you will have to do a neutral pose, an end pose. So you basically stand very straight with your arms and legs in one line for a moment. And then the second part is that you have to walk around. And then afterwards, do the end pose again. Then your calibration is done and you can start a recording in our software. And to use a recording for the Process Simulate integration, you will have to include a neutral pose somewhere in your recording. This is needed to properly scale the body dimensions in the Process Simulate software. Well, after you're done with your recording, you did all your tasks that you want to analyze, then you can HD reprocess the recording, and this will improve the data quality. Well, and then if you have that HD recorded file, you can stream the recording to Process Simulate. And setting up a streaming is within the MVN or the Xsens software quite easy. You just have to click 2 buttons and your data is sent to a network stream. So that's the part on the Xsens side. And now I would like to welcome Lucas to first introduce Siemens and the Siemens accelerometer and tell a bit about Process Simulate. And then he will also show how to use the Xsens data in Process Simulate.
Thank you, Rosalie, for the introduction. I hope that you can hear me properly. I'm very glad to be here today also with you guys. It's a pleasure to be the invitee from Xsens and to showcase the partnership we have together. So thank you, Rosalie, Vera, and the entire Xsens team. To complete and to continue, I would like to give an introduction step by step how to go onto the ergonomics analysis. But before to do so, we have to give you also a quick tips about who we are at Siemens and what do we do with the Siemens Accelerator portfolio. Within this portfolio, there are a lot of solutions that you will discover, and we will focus then on Process Simulate, which is the solution we use for ergonomics analysis, and we will see then how to digest the different information that we can gather from the Xsens and MVN inertial units. So to start with, Siemens Digital Industry Software. What do? We have a set of digital solutions that we are proposing to industrials in order to better design your product and your processes. At Siemens, we are working on a worldwide level because I'm not by myself. We got more than 26,000 employees all around the world that are supporting more than 170,000 customers. So quite a large company, and we are really focusing on a software solution. Maybe you know also our cousins who are working in the automation world and proposing you hardware for your facilities. This is not exactly the same company, but our solutions are packaged in a similar portfolio, as you will be able to notice in a minute. Then, how do we grow at Siemens Digital Industry Software? First, of course, organically, because step by step, we are acquiring more knowledge, more competencies, but also, and especially by acquiring technologies and people. We got an example here on the screen with Altair Engineering. That was the latest acquisition we've performed last year. And it's here to strengthen the portfolio with specific competencies on computational intelligence, which stands for simulation for crashes, or also a wide set of solutions regarding data analytics and specific competencies on artificial intelligence. To continue, the solutions we are proposing, they are packaged in a portfolio that we call the Siemens Accelerator. You can see here on the screen different disciplines that we are supporting, from mechanical design to the definition of the electronics components, and on the way, of course, different competencies also taking into account manufacturing. So we try to be as comprehensive as possible and creating some links between the solution. To do so, we propose openness, so we do not rely on specific technologies, and we usually are keen on working with the standards or maybe the protocols that are used to communicate with others. And this is an example, for example, with our ecosystem of partners, when it stands for publishing data for your ERP. We got a strong partnership, for example, with with SAP. And here today, we want to highlight the partnership we have with Xsens when it stands about digesting this motion tracking data. The solution that we are proposing, they are available all on a marketplace that you can find online, and you will be able to find out about the solution we are proposing, but also the one that some of our partners are packaging on top of the Siemens portfolio. So maybe one day you will also be part of this ecosystem and proposing your own solution on the marketplace. Now, the Siemens Accelerator, what we propose is really to create the digital twins of your product. So maybe more focusing first on the engineering department, making sure that you are going to design the right seat, plane, car, or even boats with our solution, and then to make sure also that you are working as efficiently as possible in the factory using the virtual solution and the digital twin of the production system. These digital twins, we use this term because it needs to be connected at some point with real data. The data coming from your product in use, or maybe from the factories that are currently running different processes. And this is based on this data that we are able to feed back in the twins that we will get even more benefits in terms of performance. The objective really here is to close the loop and continuously improve the way we are following our journey. As the portfolio can be quite rich, the idea we had was to package it in a way that is specific to the industry you are working on. Of course, when you're talking about manufacturing, we will find a production site, even if you are working in automation or in marine, but it will not look the same. You will not have to face the same frequencies challenges and in overall different problematics. So we are using the digital threads in order to map the different processes and solutions that specific industrial could use in order to solve problems in engineering or in manufacturing. And the idea is that we connect the dots so that we can help you to understand where we can help you at a first glance, and then how we could keep working together on the next stages. Now, I propose that we have a quick overview about this digital thread dedicated to engineering that we call accelerate product development, and that is used in order to better create or design the state-of-the-art mechatronics components that will go out of your engineering offices, and then to use our simulation capabilities in order to get an accurate view of the behavior the product should have in different ways or at different moments of its life cycle. Somehow here, it's important to work in a multidisciplinary environment, and we are proposing a collaborative environment to make sure the data they can connect. If you have some CAD models on one side, an electronic BOM on the other side, and a simulation software in the middle, all of these should be able to connect together. And this is also what we call a collaborative engineering innovation environment, and that we are proposing. So this is the aspect, one of the aspects that we could cover when it stands about engineering data. And now I propose that we get a focus on smart manufacturing. And here, you have designed a first model of your product. Now you need to think about how can I fabricate each part of this product and how can I assemble it. If you are thinking forward, you could already figure out how to maintain it in the time. So taking care about the processes all along the life cycle in the factory, but also for maintenance. When it stands about also managing the daily operations, we are proposing advanced production technologies like manufacturing executions or planning capabilities. And here you got a quick overview about different models and simulation we can perform in the manufacturing domain with a strong, I would say, emphasis also on being able to connect with the machines that are on the shop floor. Some that might be provided by our cousins from Siemens Automation, but also others that are provided by many different types of suppliers. Once again, the idea is to connect virtual and physical world in order to better design and then run our processes on a daily basis. And one of the solutions that you have seen in the background here is called Process Simulate, our now focus for the next slides. This solution, as mentioned by Rosalie, is used to design an industrial system. And I usually say that it has 3 pillars. The first one is that it can be used in order to simulate the process and the mountability process of a complex product. Here you got an example with a landing gear, and it has dozens or even hundreds of parts, and we need to think about the right sequence. How can I mount all these parts together? So with dedicated clash analysis, we will be able to check that the procedure, the processes proposed fits with the productivity rate and also are simply feasible. Now we can extend the simulation by also including mannequins. And this is where, and thanks to these mannequins, that we will create ergonomics report, perform our ergonomics analysis. The idea here is that we will be able to connect also our mannequin with the Xsens data. And a last topic that we will not really deep dive in this webinar, but it's important, of course, to keep in mind is that all simulation type can be also included inside Process Simulate. And with the last video on the right side, you can see a quick overview about an automated process, a robot taking care of loading, unloading different NC machines on the shop floor. And we have also a very strong footprint as we are programming robots or helping people to program robots since a few decades. To continue with Process Simulate Human, let's have a quick look to the methodologies. And we are then going to either review this through little demonstrations or videos. The first methodology is to work with your mouse and keyboard. The idea is that you will be able to create some posture for the operator using different algorithms and specific workflows that we have designed in the software in order to create the different tasks that an operator should perform. Then we will be able to apply different ergonomics analysis solutions like Rula, Reba, or also methodologies that take into account the effort. If I need to load something that is quite heavy, and to measure two aspects. The first one would be the posture, and the second one will be also to get a view about the efforts on the mannequin and then the operator's body. Second possibility is to work using virtual reality. Today, this will not be our focus, but we also are able to embed ourselves inside a virtual reality environment. The idea is that with the headset, we will be able to navigate in this environment, and it is possible then to manipulate the mannequins. Once again, there are two ways. The first one would be simply to take the mannequin by the end and to modify the posture of this mannequin. And the second one would be really to embed the mannequin so that it moves as we are doing. And the third aspect is also about how can I capture people postures on the shop floor. And we are proposing different assets here, like the capability to take a picture and then to analyze somebody's posture in a very static way in order to maybe integrate it inside of one of your virtual environments. And the second one is using motion tracking data. And this is where we will be able to use the different inertial measuring units proposed by Xsens in order to capture the data inside your factories or inside the different places where your people need to really work. And then we will be able to stream this data inside Process Simulate in order to perform the ergonomics analysis that we mentioned. Now, I would like to give you a quick overview about the first methodology we mentioned, and to do so, we will land inside the software by itself. So here we are inside Process Simulate. This is an example of a demo factory where we are assembling a battery case. And in order to perform this assembly, we are figuring different aspects. The first one would be to automate some part of the job. And we have been designing a sequence of operation where we, for example, could imagine to have this robot mounting or loading some parts of the battery modules onto the battery pack. And as you can see here, I am able, in a few clicks, to review the robot program that will be, in the end, used in order to make sure that this robot moves in a similar manner as what we have seen on the screen. But the idea here will be more to focus on manual operation. So what's up? And let's imagine that we could have different ways to work on this workstation. For example, if one of these automated assets is under maintenance. So we have also prepared, I have also prepared upfront an operation that we are going to enrich. And this operation, we will be able to see this operator performing what we usually say a get and put task. So here, this is just the operator working in 3D, but I could also turn on different tools that will help me to better understand where are the main and most difficult posture, especially by taking a look at the monitor and also the highlights on the figure of the mannequin. So this is a first capability, and as mentioned previously, we will be able to enrich this simulation. To do so, I can simply go back to its definition, and I will say that I want to add an operation, for example, to get a product. The software is asking me to position the right end of the mannequin on the battery module, which I'm doing by selecting the right end, selecting the place where this right end should be positioned. And then it is asking me about the second end for the left one. At this stage, I have simply given to the software the information about where we should go, and it is going to compute what we call a walk-to operation. And if we want, we could update the way the operator is getting this part, but here we are going to focus on the next operation, which is to position this battery pack onto the battery case. And at this stage, I'm going to reuse the operation, the location of one of the existing battery here that was available inside my model, and I will be able to review the proposal for the walk operation. Here, I did not indicate that we should not clash with this part of the product, so I could change the destination, create a slight update, making sure that my mannequin goes the right stage in front of it, and then replaying it before to why not validating. Of course, we could change the walk posture, which is the way the mannequin is working and managing also the part, manipulating the part once when it is working. And then we could press next and finalize it with this action. So there are a lot of things that we could trigger, tailor in order to make sure the motion looks as much as possible to something that people would do. And at some point, we could also leverage some analysis, for example, here, to take into account maybe some efforts that would run on the mannequin's body. And this is where we can also not only analyze a static posture, but also understand when the mannequin gets something in the end, and what is maybe the compression, and so what are the efforts on its body. To go on with this, the next phase is to go in virtual reality. So it's basically the same principle that we have seen before, but the idea is that you are manipulating your mannequin step by step with what we call the immersive posturing capabilities. And you can do it for one mannequin before to copy it for another one. We did not mention it at this stage, but it's always interesting and important to check the ergonomics aspects, not only for one population, but probably for different type of population, depending on the percentile that you are going to assess, from the smaller population to population that might be bigger. And now we land into our common world with Xsens. So this is the third methodology that we wanted to highlight and really focus for the end of this presentation. The idea is that step by step, as mentioned by Rosalie, we will be able to prepare the material, set it up on our body, making sure we understand the full body height, maybe taking into account the heels if you got big ones, in order to insert it in the body height, or maybe adding it also at the right place for the heels. So all these things, I've done it before the demonstration. That's why I'm already wearing the sensors that you can see different parts on my body. And the objective now is to show you how is it working for the recording. So you can see on the screen now my mannequin, let's say, or the recording of my motion. It's a bit a demo effect, but I have prepared the calibration beforehand, and I just need to put back my headband in order to get back on stage. It might have been, pouring a bit the recording, but this is for the demo purpose. And now everything that I'm performing will be recorded within the software, within the solution. The idea, as mentioned, is to get an end pose to start with. So being in a neutral posture, as mentioned, this is the way we are going to synchronize the mannequins inside Xsens and inside Process Simulate. And at this stage, you can see by the red circle or contour that is on the screen that we are recording all the posture that I will be taking during this little demonstration. So here I will be working on a little machine, imagining that I need to perform some maintenance task, like for example, reworking or removing that tank gas in order to better access. So I can register all these different postures, and the idea at some point would be to replay them. So I can work and create the different posture that feels like or that really embodied human aspects. Now I can access in the machine and keep working. I have no specific constraint. I would say the materials from Xsens are not intrusive, so I will be able to perform my work as I would not be equipped with such a material. And then I will be able maybe to put back all the things and keep working in a manner as long as necessary before to get back on my desk and complete the recording. So at this stage, we have created a new file. As you can see here, so it has been created at 4:31, and I would be able to stream the data. Maybe there are a couple of things that we can show here. So at this stage, what we have done is created this recording, and we will be able to replay the recording in different manner. For example, getting back step by step. So finding back my end pose. And this is where I will use it in order to synchronize with my mannequin. That's why also I got a specific feature to put it back in the end pose. Just to focus on the mannequin, I will display him only. Maybe let's keep it as is. A little bubbles here that we would remove next. And the idea is that we need to get the stream from Xsens, the stream that was mentioned by Rosalie before. So here I get the same port that was mentioned, and I will be able to connect to the data stream on that port. The idea will be then to define that Jack will be the mannequin that will be using the data, and we will make sure that we match the joint angles from the data captured by Xsens and the one that are in Process Simulate. So at this stage, I will put it on both screens, and we will keep it separated to show you that the mannequin are moving accordingly. So there is a bit of noise, I would say, based on the calibration aspect for the demo purpose, but the idea is here, and we will be able to stream it accordingly. Also, we got some dedicated tools within the solution in order to correct a bit, also based on the noise, in order to reposition the tracked human if you want to place it inside an environment. And this is how, at some point, you will be able to get the data in a virtual twin environment and to complete the analysis you want to perform with the physical data streamed inside your virtual environment. If I want maybe to go back to another example that I've done up front, the idea could be also to jump back from an example to another. You could have different recordings that have been created in a dedicated session with the operator, and then you will be able to assess step by step all of them. So, for example, if we take the case of the battery lift, which is another recording that I've done upfront, we will be able also to get at this moment where we have the famous end pause. We will also have the operator standing inside this end pause inside Process Simulate and connecting both environments through the tool that we just showcased before. And then we can, as you have seen, replay. So this is a recording that I've done wearing the headset from virtual reality, and this is basically the pose that I was having in order to put this headset on my body. Okay, so that's overall the way we are recording the data, and we are getting this data inside a standalone file that we call the MVN, that you can reuse as much as possible in order to create the posture within Process Simulate. And in the coming weeks, we are going also to publish renewed materials that you will be able to better or to complete your understanding about the different processes here, replaying the different stages that we mentioned about setting up the devices, calibrating the data, and then getting back the data recording the data with Xsens and streaming them inside Process Simulate. And at this stage, once you got the data in processing, keep in mind that you can apply the different ergonomics analysis that you would like to reuse and operate. Okay. In order to complete, one thing that we could add is just the fact that at some point, if you are manipulating, for example, heavy items like this gas tank, you want maybe to highlight also some loads that can be applied on the mannequin body. And that is something that can be created, that can be defined upfront, and that would be taken into account inside your analysis also. Now, in order to, I would say, complete my presentation here, I just wanted to highlight, in order to conclude, three key benefits. The first one is that thanks to our technologies, we will be able to help you define your workstation. The idea is not to reinvent the wheel every time, so reusing your digital twins from station A can help you to accelerate the station or the evolution for station B. The second aspect is to work with standards in order to make sure, based on ergonomics data, that the operation that you are going to propose and implement on the shop floor are not too harmful for the people and the workforce overall. And then connecting the data, you know, it's part of the DNA. So connecting the data from our partner Xsens with the mannequin inside Process Simulate, in order not to only use motion that have been engineered by your people using Process Simulate, but also to reuse really motion tracking data that have been, I would say, populated by the people that are actually performing the job on a daily basis. So that was all for me here. Rosalie, I hope it was a good overview, and once again, thank you for this invitation, and thank you for also the entire team that is helping us creating this webinar today.
Thank you, Lucas. It was very clear to me, and thank you also, for the clear presentation. If you, as a viewer, would like to be contacted by Xsens or Siemens, then there will be now a pop-up in this webinar port, and you can fill that in, and then we can contact you. There are some questions, so Lucas and I will try to answer them. Let's start with the first one. Can Xsens be used with virtual reality? Yes, there are a couple of options for that. For example, we have a plugin in Unity and Unreal. And we have a knowledge base in which you can find information how to use these plugins. And more, if your question is more related to Process Simulate, I think, Lucas, if you agree with me, is one option to show the environment as if you are seeing from the person's eyes.
Indeed.
Yeah. Okay, and I hope this one answered the question. Then we will go to the next one. That's a bit more for Lucas. Will the next version of Process Simulate includes MTM analysis without a third-party software? And will it be able to connect with Tactic?
Okay, so there are two aspects on that question. To be frank, I'm not very familiar with Tactic. So I'm not sure to be able to provide you the right information on this topic. But about the MTM analysis, I'm sure that our R&D is actively working on this topic. And I'm aware about the MTM summit that will happen next year in April, where we are going to do a joint presentation, Siemens and MTM. So, you know, the ecosystem is growing, and we are trying to include such a standard as much as possible in our solution. I'm not sure about the time frame, the roadmap, but this is something that we could also tackle offline. And if you are going on this summit, maybe we will meet. I will also try to join the conference in April.
Thank you. Okay, let's move on to the next question from James. Do you have gloves that show the fingers and hand movements in more detail with Awinda? So yes, we do have an integration with the gloves made by Manus. They have multiple kinds of gloves, and you can use those gloves in combination with both our Awinda and our Link, and then also record the finger data. This can also be streamed. Maybe, Lucas, you can say a bit more about the Process Simulate side of things.
Yep. So I think there are different use cases when you are going to work with the gloves. The first thing I would like to notify is that when you are launching the MVN software from Xsens, you will notify that there is somebody wearing the system plus the Manus gloves. So Manus is a partner, a joint partner somehow from Xsens and also from our side. Because when you are, so there is a way to stream the entire body data. And for the gloves, we are also having the capability to use them in a virtual reality environment. So when you are going to manipulate different items, if you want to have a focus about the fingerprints, this is definitely something feasible also.
Great. The other question is a bit related to that. Is the hand pressure onto the objects also recorded? So it's not recorded, but maybe it's simulated in the Process Simulate software.
We could add it as a I would say on top information. This is probably the last slide that I highlighted. This is where we could add different type of loads that would represent the forces that could be positioned either on the center palm of the hand or at different locations on the body. And this is something that we would take into account also when we are recording or capturing an ergonomics report, because the loads also definitely have an impact on the body and on these reports also.
Yes, I hope that answered the question. Then another question is, does the mannequin have to match the height and weight of the person using the trackers? You can, in the Xsens software, you have to fill in the body height and the foot length. And then with that neutral pose, you can scale it, the body dimensions automatically in the Process Simulate software. Siemens, Lucas, if I'm not wrong, there's also an option to fill that mannequin's dimensions in the Process Simulate software itself.
Exactly. But the idea is to be able to record a set of posture for the person that is wearing the equipment. So we will start with, let's say, Lucas, 1.85 m. And inside the Process Simulate, we could record the set of posture and then apply, because the mannequin is anthropomorph, let's say, it can change size. I cannot, but the mannequins can. So we would reuse the posture that have been recorded through the operator job, that is maybe 1.85 m, and then we would try to reinsert it in a mannequin that is 1.65 m. The idea is that it will match, as we have seen, the joint angle. And then we could maybe do slight modification within the software with our mouse and keyboard in order to make sure that it has the same reach or not. And at this stage, we could also somehow complete the analysis with different type of population.
Yeah, so you could actually play around with those lengths and the heights of the mannequins. I think then there are two questions that are already answered a bit about the finger movements and the loads. So then the next question is, for wrists, do the results display angles, movements, or speed? So what we record and stream in the Xsens software are angles, positions, velocities, accelerations, multiple kinds of output parameters. The way that is given in the Process Simulate software, if I'm right, Lucas, is not really with graphs, but just by the motion.
Mm-hmm. So yeah, it's about really mapping the joint angle. That's what we are trying to get, and that's also why it's important, I think, to have this neutral posture in order to synchronize both worlds. Yep, that's how it's working here. I was also trying to anticipate the next question. Hopefully it's enough for that one, about the capability to stream the data all in one with the Xsens materials and the Manus gloves directly into Process Simulate, and this is something we need to investigate. I'm not sure about the workflow right now. Maybe this is a side note that we need to check and come back to the person who is asking the question here.
Yes, that sounds like a good idea. Then I will continue to the next one. The next question is, will there be an option to transform the Xsens recording to a task simulation builded one? So the recordings that are made in the Xsens software, the only thing you can change about them is you can improve the quality by HD reprocessing, and you can do some editing about contact points of the feet with the ground, but you cannot really change the movements, because then you are going to simulating movements again instead of measuring movements. So within the Xsens software, it is not possible. Yeah.
Maybe to complete, this is something that we could do then more on process simulate side. Maybe Olivier, we could have a quick look to the screen to complete this topic. But here, basically, the motion that this person is going to take are posture that I've recorded through Xsens. The idea is that once you have set up your Xsens stream, you could turn on what we call the posture recorder, and you can record all the postures that have, that this mannequin has taken. And the idea, maybe we can give a very short example, is that it is going to record them and then create the task simulation builder accordingly. You can then just reuse it in a specific recording, and you would be able probably then to modify some of the postures. The only thing that you need to keep in mind for the people who are, let's say, used to work with Process Simulate here is that it will be more like a different legacy, I would say, frame for the operator. So switching from a posture to another with different frames that are going to be adjusted together. So it's not really a task simulation builder, but it could fit also by supporting simulation.
Yeah, thank you. I think that's a nice example. The next question is, can we get CSV data from this? When you mean from this being Xsens, CSV is not one of our exporter types, but we do have other exporter types depending on the type of license you have. For example, with the Analyze Pro license, you can export to Excel, and then it will be easy to convert to CSV. Lucas, I'm not sure if there would be an option to have a CSV in Process Simulate exporter.
For different type of simulation, we are able then to export the reports, and in some type of reports, you get some raw data. Now, it's more for static posture that we are doing so usually. So this is if you need to get CSV data, you could complete, I would say, the journey, and from your report also gathering the data. I think it would be interesting also to get the use case behind it, because I guess we prefer to have a report with that is applicable against some specific methodologies before to have raw data, but to be investigated.
Yeah, good one. Thank you. Next one is already answered by my colleague. Can you provide an example case? Well, we're working on that, so keep an eye on our LinkedIn, and then you will see our customer case upon this topic. Then another question is, how do you match tasks with the motion data in Process Simulate? So I think then you mean how do you label certain tasks in Process Simulate? Lucas, can you explain a bit about how people can identify certain tasks in Process Simulate or label them?
Sure. The idea would be to, if you want to map with probably different tasks in Process Simulate, for those who are, I would say, knowledgeable with the solution, you can create a sequence with different simulations. So you could imagine to have one simulation where the machine is going to present different, I don't know, tools or parts to an operator, and then have a sequence where that would be based on Xsens, where the operator is going to take all these components and remove it from the machine. So the solution is open on this topic, and you can easily mix simulation that have been designed within Process Simulate and simulation that comes from Xsens without any issue. There might be some topics about synchronizing the tasks all together, and in order to make sure you got a realistic scenario in the end.
Yeah. So the next question is, would you have any vision to simulate sport fields? So that's an other world than the work floor. So what is an option with our Xsens software? We have that network streamer that is used also to stream data to Process Simulate. But you can stream data to any platform that can receive data via a network port. So, for example, a platform that can simulate sport fields. From the Process Simulate side of things, I think it's, correct me if I'm mistaken, it's more focused on workstations and such. But if I think this question is from Mechni, if you want to talk about this from the Xsens side, please reach out to support@movella.com, and we can talk a bit more in detail about this.
Mm-hmm. Definitely a question dedicated for you, Rosalie.
Yeah, good, that was a correct assumption. Then a question from the chat. Do you collaborate with researchers at university for ergonomic studies? And what is the maximum duration that tasks can be recorded for future rewatching and data analysis? Yes, we do collaborate with researchers at universities for ergonomic studies. So we have multiple options, multiple parties we collaborate with for ergonomic studies. The maximum duration, I think there is not really a limit. It also depends a bit on the second software you use for it. So there are other options than Process Simulate, but it depends what kind of software you use. And but furthermore, there's not really a maximum for the duration. Yeah.
Maybe to complete here, Rosalie, I've done some recordings that are 20 minutes, 30 minutes long. Then probably the idea within this recording is that not the entire recording will be valuable. You will probably want to isolate and evaluate, I would say, some specific parts of the processes that you are currently investigating. So this is definitely something that you can do. Perform a long recording. Do not hesitate to, do not forget, I would say, to do the neutral pause at the beginning, at the end, or in the middle, just so that you get a synchronization aspect and point, I would say. But then you will be able to, from this 20 or 30 minutes recording, isolate 10 tasks from 20 to 30 seconds without any issue.
Yeah, that's indeed a good point you make there. Then I think we have to go to the last question given the time. For other questions that remain, we will try to answer them in the chat, and otherwise, please reach out. If it's more an Xsens question, reach out to Xsens, and if it's more related to Siemens, So the last question is, what extensions of files can be exported and imported at Process Simulate?
That's for me, I guess. It's we are quite open. So the favorite 3D files that we prefer is JT, but in the end, we are open to most of the CAD files that you often meet in the industry. So we can import inside Process Simulate a step file, a CAD product, or other type of of extensions that you like. In any case, at Siemens, we provide also dedicated CAD translator that we can use either integrated inside Process Simulate or in parallel in order to get the 3D data you want inside the scene.
Then another question, can we directly feed the load data from hand sensor to Process Simulate? And added to that, can we sense the push-pull force data? So I think that would include a third party, like next to the Xsens and Process Simulate. Can you tell a bit about the options for that, Lucas?
At this stage, I would need to investigate a bit more. So if you want that we get maybe an additional conversation on that one, I want to understand where comes the load data in order to see what would be the best way to integrate. We are offering different, I would say, APIs in order to automate different things in the solution. So that would be a way maybe to answer that type of question, or maybe to go for a specific R&D project. I'm not sure really at this stage.
Yes. So another question is, does Xsens sense somatotype of a person? So I think you mean with that like the ratios between muscles and fat of a person. How broad are the shoulders, for example. So it doesn't sense it, but it does give you the possibility to fill out all the body dimensions in the Xsens software. So on default, you can just fill in the body height and foot length, but there's also an option to say show more and then fill out like all other body dimensions, like the width of the shoulders, the length of arms, of the hips. So you can fill that out. It is important that you really know how to measure those, and we have tutorial videos and also a webinar on this. Because you really must like palpate the right points to make those measurements correctly. And if you want, you can use that to really customize the body dimensions of the user in the software.
Mm-hmm. And maybe to complete, if you are including this kind of information into Xsens, this is also things that we would integrate inside Process Simulate.
Another question, can we simultaneously process 2 or 3 mannequins?
So in terms of recording, we would do it one by one. So recording, let's say you are doing a recording session using Xsens materials. So you would first record, I guess, operator 1, then operator 2, then operator 3. And you could then create the simulated mannequin for each of these operators, and then combine them into a single operation, a single simulation, where you would see all these people working together, maybe to check different coactivity topics, or just to better understand the entire process. So I guess there are 2 things: recording step by step, streaming in the data inside Process Simulate, and then create a kind of a macro operation that will help you to oversee the entire actions of the mannequins.
Yeah, and to add to that, it's also possible within the Xsens software to record multiple persons at the same time. And then also it's possible to split that up to different characters. So if you want to analyze the interaction between people, you can record it with everyone in the same session, and then split it, stream them one by one, and then edit later. Can we combine Xsens motion capture along with immersive headsets? With the immersive headset, I think you mean the VR headsets. Yeah. Yes, there we have integrations with, for example, Unity and Unreal, in which you can use the plugins to use Xsens data in a virtual reality world. And there's also the option, as Lucas showed in the Process Simulate software, to kind of get the viewpoint from the person's eyes. So then you also have a sort of virtual reality view.
Mm-hmm. And the recording, one of the recording that I showed you, and maybe Olivier, you could have it on screen for just 5 seconds, is basically a recording that I've done when I was in VR manipulating a battery module to put it in a battery pack. And basically, this is a recording that I've created from a VR environment. So now this is desynchronized as I created the recording within Process Simulate. So basically, whenever you are in VR, you could also use your Xsens materials. The process would be different than if you are using another type of technology. Maybe you are using Vive tracking. It's a bit different, but that's something you can do definitely.
Yeah. So I think those were the... Oh, another question is popping in. The question is, after getting familiar with setting everything up in Xsens, how long does it take on average to set everything up? About 10 minutes. So to put all the sensors on the body and to do the calibration, it will take you about 10 minutes.
Mm-hmm. That's what we are doing now on an everyday basis, and I'm trying to do some records, you know, to set up the different things in the specific order in order to be as efficient as possible. But once you got it on the body, this is very stable, and you can wear it for a couple of hours. The limitation then would be the battery, but it's quite long here.
Yeah, the battery life of those sensors in the Awinda is 12 hours. So most working days are a bit shorter than that. Okay, I think that's clear then. I hope at least. And otherwise, don't hesitate to reach out to us. Then I would like to thank Lucas. And of course, I would like to thank everyone for attending this webinar. And have a nice day.
Thank you very much, Rosalie and the team. For the other questions in the chat, we will try to come back to you as soon as possible. And I wish you also a very good day. Thank you very much.